of the Smithsonian's National Air and Space Museum. It is my pleasure to welcome you here today to discuss the nation's report card in science for 2015. Since 1969, the National Assessment of Educational Progress has been America's yardstick for student ability. Today, we'll hear the results of the nation's 4th, 8th, and 12th grade students in physical, life, earth, and space science, critical areas for success in a world more and more dependent upon STEM disciplines. Since 1976, this museum has educated and inspired the world with some of history's most famous milestones in those very same subjects. We spotlight the scientists, engineers, inventors, and innovators that changed the world and tell the stories that can spark a lifetime of curiosity and learning. The skills necessary to build a flying machine, calculate the orbit of a spacecraft, or discover new planets around distant suns are rooted in scholastic abilities measured by today's assessment. But there's more to history's greatest adventures. Creativity and imagination are critical to believe that a once impossible dream is within grasp. The Wright brothers took early inspiration from the work of one of history's greatest artists, Leonardo da Vinci. Many of the first astronauts heard their first calling as children in pages of science fiction. Museums can be forums where we celebrate the high watermarks of history, where the arts and scientists meet. But they can also be laboratories to encourage the skills and spark the imagination of new generations. The National Air and Space Museum works to create innovative models for informal education and to build bridges to the nation's formal education systems. One of our most successful programs to that end has been STEM in 30, a fast-paced, interactive exploration of STEM topics with museum experts beamed directly into classrooms and broadcast on NASA TV. One of the show's hosts, Marty Kelsey, is here to moderate the panel discussion of today's National Report Card, and you will hear more from him a bit later. I'd like to thank the U.S. Department of Education and the National Assessment Governing Board for being here today. And our institutions can change the way schools and museums work together and ensure that a century from now, these halls are filled with new stories of achievements we can't yet envision. It's now my pleasure to introduce the Chief Executive Officer of Change the Equation and member of the National Assessment Governing Board, Dr. Linda Rosen.
Thank you so much, General Daly. Your leadership in science education and the National Air and Space Museum's contribution to science learning make this the perfect setting for today's event. I must confess, when I first walked into the space, my reaction was, wow. And I couldn't even quite get past that. This is an incredible setting. We're so grateful to have the opportunity to release the results for the nation's report card 2015 Science here. We're also grateful with the Smithsonian to partner with the Smithsonian at the largest of its 19 museums and galleries and combining its 2 landmark locations, the most visited museum in the country. The Smithsonian is revitalizing education through its programs and operations. It serves as a laboratory to create models of innovative, informal education that link to the formal education system. Many thanks to everyone in attendance here at the museum. There are lots of familiar faces. And also to everyone joining the webcast. I suspect there's some familiar faces there as well. I'd also like to express thanks to the National Science Teachers Association for supporting today's event and for its tireless efforts on behalf of students, parents, and teachers across the country. As you heard, I'm Linda Rosen, Chief Executive Officer of Change the Equation. Our group works at the intersection of business and education to ensure that all students graduate high school STEM literate. We do that by collaborating with schools, communities, nonprofits, and states to adopt and implement excellent STEM policies and programs. I'm also a proud member of the National Assessment Governing Board, an independent, nonpartisan board whose members include governors, state legislators, local and state school officials, educators, business representatives, and members of the general public. Congress created the 26-member board in 1988 to oversee and set policy for the National Assessment of Educational Progress, or NAEP, also known as the nation's report card. It's an exciting time to be on the governing board. For me, it's brought out my inner policy wonk all over again. But with this report, NAEP has measured all STEM subjects, that's science, technology, engineering, and mathematics, over the course of a single year. The report that we'll discuss today features national and state-level results at grades 4 and 8. It also includes national results at grade 12 from NAEP's 2015 science assessment. The assessment measures students' knowledge in physical science, life science, and earth and appropriately space sciences. It also measures how well they implement science practices, like using scientific principles and engaging in scientific inquiry. Well, let's get on to the assessment. Just like our students, your knowledge of science was measured this morning. You were asked to answer 3 questions, and those 3 questions were taken from an actual NAEP science assessment. Let's see how we did on the first question, which came from the 4th grade assessment. It asked, which statement explains why light from the sun can warm up water in a glass? Dum-da-da-dum. The correct answer is D. Water absorbs light energy. It looks like 93% of you got that correct. So, okay, yay for 4th grade. We'll discuss the results of the other questions later in the program. Before we begin, I'd like to share the schedule of our program. First, the science assessment results will be presented. I will have a few minutes to offer some remarks, and after that, our distinguished panel will explore how lessons and activities inside and outside the classroom help students acquire scientific knowledge and literacy in today's STEM-driven world. We want to make certain this event is a discussion with both our in-person and remote audiences. Those of you tuning into the webcast, please feel free to submit a question at any time during the event. Just type your question into the chat tab on your screen and click send. Those of you here in the audience will have to use the old-fashioned raising your hand during an upcoming Q&A, which we'll describe later. We also encourage your ongoing conversation on Twitter using the hashtag, this is 2016, NAEP. Now, it is my great pleasure to introduce Dr. Peggy Carr. Dr. Carr is the acting commissioner of the National Center for Education Statistics, or NCES. She is one of the nation's most foremost experts on student assessment, having guided the NAEP assessment for many years. What's missing from the bio that I got is that Peggy also holds the Guinness World Record for juggling the most balls without dropping any. And I say that having seen her in her workplace and doing what she does with great frequency. While Dr. Carr makes her way to the stage, let's take a look at our second question, which came from the 8th grade assessment. That question asks why earthquakes occur near the San Andreas Fault. The correct answer is C. Portions of the plates get stuck and then suddenly loosen and move. Oops, it looks like 49% of you answered that correctly. We need to do a little more work on our science. Dr. Carr?
Well, thank you, Linda. That was kind of fun and nostalgic here, and I want to add my thanks from the U.S. Department of Education for having this event here today. So General Daly and others here in the museum, thank you. So let's get started. The results I'm going to be releasing today are for a national assessment of students from public and private schools across the nation, grades 4, 8, and 12. The last time science was assessed at all 3 grades for the National Assessment of Educational Progress was 2009. The assessments were administered in January through March of 2015. We had 115,000 fourth graders, 111,000 eighth graders, and 12,000 12th graders. In 2015, we have results for the nation, 46 states, and the Department of Defense schools. Trial Urban District assessment results are not available this time around, and we do not have results for a limited number of states. They include Alaska, Colorado, Louisiana, Pennsylvania, and the District of Columbia. Remember, this is a voluntary assessment, not mandated. Student performance on NAEP is reported in a couple of ways: scale scores from 0 to 300, and achievement levels, basic, proficient, and advanced. So let's get started with grade 4. In 2015, the average scale scores for 4th grade students was 154. This was an increase from 2009, when the average score was 150. This is indicated that is a significant increase because of the asterisk, and you're going to see this throughout this presentation this morning. Scores are also reported using percentiles to show results for students performing at the low, 10th, and 25th percentiles, middle, 50th percentile, and higher levels, that would be the 75th and the 90th percentile. And as you can see, all of the scores are rising for these percentiles. This slide shows results for 4th grade students at each achievement level. 4th grade students performing at or above proficient are able to demonstrate competency over challenging subject matter. As you can see to the far right of this figure, 38% of 4th grade students scored at or above proficient in 2015, which was higher than the 34% that we reported in 2009. On the left side of the figure, you will see that there was a lower percentage of students scoring below basic in 2015 compared to 2009. Now, this figure shows the 2015 grade 4 science scores by race, ethnicity, and gender. So, for example, white students had scores that increased by 3 points in 2015 compared to 2009. Scores are higher for all of these student groups compared to 2009, as you can see here. However, note that scores for Black students and Hispanic students increase at a faster rate than their white 4th grade students' counterparts. Continuing with our look at student groups, we see that 4th grade science scores were higher in 2015 for all school locations and eligibility for the National School Lunch Program. 4th graders attending schools in cities had a score of 148, lower than the scores for students attending schools in other locations, suburbs, town, and rural. Grade 4 scores were also higher in 2015 for students who were disabled or English language learner students in comparison to the last time we administered this assessment. This figure shows the 2009 and 15 score differences between white and black students. 2009 scores are shown on the left and 2015 scores on the right, with the score differences shown below in the dark blue circles. Now, the score difference between black and white students was smaller in 2015 compared to 2009. Scores increased for both groups since 2009, which is really good, but the scores for black students was larger and helped to narrow the difference, the good way to close gaps. The score difference between white and Hispanic students also narrowed since 2009, 32 to 27 points. This 8-point difference for the increase for Hispanic students led to the same sort of pattern of narrowing of the gaps in comparison to their white counterparts. Now let's look at some maps. This map compares student performance by state in 2015 with 2009 for the 44 states and jurisdictions that participated. 18 states or jurisdictions had higher scores, as shown by the dark blue. The medium blue indicates the states where scores for the 2 assessment years were not significantly different, while the white indicates states that did not participate in either 2009 or 2015, and therefore we have no trend data. Now, the gray indicates a score decrease from 2009. For states and jurisdictions shown in dark blue, that would be Arizona, Tennessee, Georgia, and the Department of Defense schools, had significantly higher average gains, score gains, than their nation's public school students. This 14 states in medium blue had score gains that were not significantly different from the nation, and this is shown in the green near the bottom of the chart. That's the nation. These states in bold font had an average score or average scores in 2015 that were greater than the national public average. These states shown in regular font had scores that were not different from the nation, and the italicized states shown here had scores that were lower than the nation. So now let's turn to the 8th grade results, and I want to remind you that we have a 2015 in comparison to 2011 data point, and that's because in 2011 we did a linking study with the Trends in International Math and Science study. You probably know it as TIMSS. In 2015, the average scale score for 8th grade students was 154. This was an increase from 2011 when the average scale score was 152, in comparison to 2009 when the average score was 150. At all percentiles, the scores in 2015 were higher than in 2011 and in 2009. This slide shows the percentage of 8th grade students at each achievement level and below basic. The achievement level below basic is not an achievement level, but basic, proficient, and advanced are official levels. As you can see on the far right side of this figure, 34% of 8th grade students scored at or above proficient in 2015, which was higher compared to 32% in 2011 and 30% in 2009. On the left side, we see that there was a lower percentage of students scoring below basic in 2015 than in both 2011 and in 2009. This figure shows the 2015 8th grade science scores by race, ethnicity, and gender. For example, white students had score increased by 2 points in 2015 compared to 11, and 4 points in comparison to 2009. Scores were higher for all of these student groups in comparison to 2011, except for students who were Native Hawaiian, other Pacific Islanders, American Indian, Alaskan Native, and 2 or more races. Scores were higher for all of these student groups in comparison to 2009, except for students who were American Indian, Alaskan Natives. Average scores for female students were higher than their male counterparts in comparison to 2011. Continuing with our look at student groups. We see at grade 8, science scores were higher in 2015 in comparison to 2009 by school location and eligibility for the National School Lunch Program. We see again higher scores in 2015 in comparison to 11 across the groups, with the exception of town and rural school locations. 8th graders attending schools in cities had a score of 148, lower than scores for students attending schools in the other locations, the suburbs, town, and rural. Students without disabilities scored higher in 2015 compared to 2011 and 2009, as did English language learners and students who were not English language learners. There were no score changes for students with disabilities during this time period. This figure shows 2011, 2009, and 15 scores and scores between Black and white students. The score differences are shown on the top, and the figure or the information in circles at the bottom represents the differences. These score differences between white and Black students was narrower in 2015 compared to 2009, and not significantly different in comparison to 2011. Scores increased in 2015 for both groups since 2009 and 11, but the increase for Black students was large enough to narrow the difference, something that we saw again for the 4th grade, and the white-Black score difference narrowed from 36 points to 34 points. The difference between white and Hispanic students also narrowed during this time period from 30 to 26 points, and was not significantly different, though, for the 2011 comparison. The 8 points, again, helped to narrow the difference between white and Hispanic students because the Hispanic students were making greater gains. Now let's look at another map. This map compares student performance by state. 24 states or jurisdictions had higher scores, as shown by the dark blue. The medium blue indicates the states where scores were not significantly different, while the white states show which states had no change in their data, or where we had no data, I should say. As you can see, no state showed a significant score decrease from 2009. 3 states, Utah, Tennessee, and Nevada, had score gains greater than the nation at grade 8 since 2009, indicated here by the dark blue bars. The 20 states in medium blue had score gains that were not significantly different from the nation. Wyoming, shown here in gray, had a score smaller than the nation. These states in bold font had average scores in 2015 that were greater than the nation. These states shown in regular font had scores that were not different from the nation, and these states had scores that were lower than the nation. This map compares student performance by state in 2015 with 2011 for the 46 states and jurisdictions that participated. 12 states or jurisdictions had higher scores, as shown again by the dark blue. The medium blue indicates the states where scores for the 2 assessment years were not significantly different, while the white indicates states for which there was no data. And we have 1 state in gray, representing a decline in performance in comparison to 2011. Two jurisdictions with dark blue, that would be Tennessee, and the Department of Defense schools, had score gains greater than the nation at grade 8 in comparison to 2011. The 10 states in medium blue had score gains that were not significantly different from the nation. Again, states in bold font had average scores that were greater than the nation. States shown here had scores that were not different from the nation, and these italicized states had scores that were not lower than the nation. Now this slide shows the states that had score increases and decreases by grade in comparison to 2009. This is a nice summary slide. 3 states had score increases at grade 4 only. 1 state, Delaware, had a score decrease at grade 4. 9 states had score increases at grade 8 only, and 15 states had score increases at both grades 4 and 8. Again, a nice summary. Now, let's turn to grade 12. In 2015, the average scale score for 12th grade students was 150. This was not different from what we reported in 2009. The scores in 2015 were not significantly different from 2015 in comparison to 2009 at any of the 5 percentiles shown here. On the right side of this figure, you see that 22% of 12th grade students scored at or above proficient in 2015. This was not significantly different from what we reported in 2009. This figure shows the 2015 race, ethnicity, and gender data. For example, white students had an average score of 150, which was not significantly different from the average score that we reported in 2009. Scores were not different for any of the subgroups shown here. Continuing, a quick look at student performance, subgroup performance, we see that scores were not different in 2015 compared to 2009 by school, location, or the highest level of parental education. Grade 12 science scores were also not different in 2015 for students with disabilities and English language learners. To help contextualize these results, we asked students which courses they had taken from 8th grade until the present. The percentage of students in each group by year is indicated in the bold green font here, while the bars indicate average scale scores, with 2015 scores in dark blue and 2009 scores in medium blue. What you see, as indicated by the asterisk on the 34, the number 34, is that more students in 2015 are reporting having taken biology, chemistry, and physics compared to 2009. These students' scores are higher than those who took only 2 of these courses, biology and chemistry, or biology only and something else. This finding suggests that the more science courses a student takes, the better he or she performs on NAEP. Notice that as the percentage of students taking more science courses increases, the average score for this group has decreased, as indicated by the asterisk, and that would be next to the 166. Well, there are a lot of possible reasons for this, but one potential explanation is that we are observing more students who are in the below basic category taking all 3 of these courses, as well as an increase in students who are English language learners and students with disabilities and students who attend schools that are high poverty or as indicated by eligibility for free and reduced price lunch. So now let's summarize. I just gave you a lot of data, a lot to hold in your heads. Just want to give you some highlights before we turn it back over to the question and answer part. This is a screenshot of the homepage for the 2015 NAEP Science Report Card. It's online. It summarizes the data very nicely. In 2015, students at grades 4 and 8 scored higher compared to 2009, and there was no change in scores for grade 12 students in comparison to 2009. And remember that extra data point for grade 8, we did see an improvement. Additionally, the percentage of 4th and 8th grade students scoring at or above the proficient level, these data pretty much mirror what we see here for the scores. This slide summarizes the performance gaps for selected student groups. Score differences between some students were smaller in 2015 in comparison to 2009. Now the arrow directions, the direction of the arrow denotes the change in comparison to 2009. Although not indicated here, in 2009, we did observe a score gap between boys and girls in the 4th grade, but boys scoring higher. They scored higher in 2009, but that difference is no longer evident in 2015 for 4th graders. The score gap remained in 2015 for 8th and 12th graders, although that 8th grade gap did narrow a little bit. The numbers in the dark blue denote the size of the gap in 2015, while the gray diamond indicates no significant differences in scores. Again, there was no difference in overall science scores between male and female students at grade 4. Greater score gains for Black and Hispanic students contributed to the white-Black and the white-Hispanic score difference narrowing in comparison to 2009 for both grade 4 and grade 8. And that 12th grade is sort of holding steady there. Although these gaps that we are noticing here are narrowing, I want to point out that they are still large and unacceptable. So again, go to the nation's report card. This is just a smidgen of the data that we have available through our report card, our online report card, especially the state pages in our NAEP Data Explorer. I want to conclude by thanking those who helped us bring this data to you today, the students, the teachers, the schools, our state coordinators who made this all possible, the authors of the report, the analysts of the report, and those at the National Center for Education Statistics who helped pull all of this together. So thank you.
Thank you so very much. Lots and lots and lots to absorb, and obviously it's going to take some time. So I want to take a couple moments and also reflect, but I'm putting on a different hat. It's not the NAGB hat, but it is rather my change the equation hat. So like you, I'm asking myself, so what's going on with 12th grade? While it's heartening to see improvement for grades 4 and 8, it is quite worrisome that there was no improvement of NAEP scores between 2009 and 2015 among high school seniors. Senior year is the launching pad to post-secondary learning, whether it is formal higher education or on-the-job training. Equally troubling, as Peggy mentioned, is the fact that only 22% of 12th graders perform at or above proficient. That means only 1 in 5 seniors are ready for challenging work in science. Yikes. No wonder that employers are worried. According to Change the Equations analysis, STEM jobs will grow by more than 2 million over the next decade. And of this total, roughly half are healthcare-related jobs that clearly require strong science background. Will there be enough future applicants to fill the openings? And if not, which frankly seems likely, what can we do to accelerate improvement? Change the Equation partnered with Amgen, a leading biotechnology company that creates medicines for patients with serious illnesses, to begin to get a handle on answers to these questions. We commissioned a survey of high school sophomores, juniors, and seniors for their ideas about ways to strengthen science education for teens. And here's what we learned. First slide, please. Teens overwhelmingly believe that science is interesting and relevant, but when it comes to science classes, they are lukewarm. 81% of teens say science is interesting, but only 37% like their science classes a lot. Oh, be still, my heart. To give this some context, nearly half of the teens report liking their other classes a lot. Another result, teens are savvy consumers, and they know that their classes aren't giving them the experiences most likely to engage them. The survey results merely echo decades of research on science education, as many of you will immediately recognize. Teens want hands-on lab experiments, they want more field trips, they want virtual experiments, and they'd like their choice of topics for further study. Unfortunately, their preferences do not align well with the learning techniques most often used, which are classroom discussions or teaching straight from the textbook. The last result I'll mention, and appropriate for this slide, is particularly appropriate for the business community, and that is the need for real-life exposure to science careers and professionals, because teens have very few pathways to informed career decisions. For example, only a third of teens know an adult working in a scientific career, but nearly 9 out of 10 wish they knew someone. And low-income students face even greater hurdles. Only 19% said that they know someone who works in one of the biological sciences. So here we see a list of things that teens want but lack about career exploration opportunities. These are clearly a charge to the business community, a charge and a challenge that they have willingly stepped up to address. Companies generously contribute their time and talent to enrich students' education, and they contribute money to support worthy learning experiences for students, teachers, and adult youth leaders, all in the spirit of strengthening STEM learning. But they also bring impatience and concern, and that relates to the numbers I started with. While the 2015 4th and 8th grade data is heartening, until it is sustained all the way through high school, and the number of youngsters reaching proficiency rises significantly, we all have our work cut out for us. The results of other questions that NAEP asked test takers and their teachers do suggest some promising ways to start. The fact that 8th graders who participated in regular hands-on activities and investigations in class outscored those who did not have such opportunities validates recent nationwide efforts to promote hands-on learning in science, both in and out of school. And this is especially important since we know from Change the Equation survey that young people prefer active learning. Of course, the relationship between hands-on learning, museum visits such as this incredible facility, and NAEP scores are correlations and don't prove causation. but we must act on the best information available rather than sitting on our hands. The business community will continue to do its part. I can assure you of that. Back with my NAGB hat, let's take a look at the results of our third and final question, which came from the 12th grade assessment. The question asked, what is a property of all galaxies? I wonder why they picked this question for today. The correct answer is C. All galaxies contain a large number of stars. Based on the result, it looks like 52% of you are well-versed on space. We did better than we did in 8th grade. And all the more reason to explore the museum after our event. General Daly didn't have me say that. Now it's the time for our panel discussion, which will be moderated by Marty Kelsey. Marty is a National Board certified science teacher who taught at the elementary and middle school levels. He's now the education specialist for digital learning and host of STEM is 30 at the National Air and Space Museum. As he and the rest of the panelists make their way onto the stage, please watch a new video produced by the National Assessment Governing Board that highlights contextual data from the report card. Video, please.
When I grow up, I want to be a marine biologist. My parents think being a scientist is a good idea. Plus, my teachers make science interesting and fun. I love working with all the cool tools in the lab. It makes science come to life for me. I also like working with my lab partner. You get to come up with ideas together and learn something more than you could on your own. I think you can make your dreams come true with a little bit of help and a lot of hard work. For me, that's a job in science. But until then, I'll keep enjoying the 8th grade.
Great video. It underlies the importance of exploring factors inside and outside the classroom that contribute to student performance. And let me now turn the podium over to Marty as I put my STEM hat on.
All right, well, I'm Marty Kelsey. I am a lifelong educator. I taught elementary school for a long time. I taught middle school science and broadcasting, but ultimately, I'm a science nerd. I've been a science nerd since I was in 2nd grade. I can vividly remember getting a book order one day when I was in 2nd grade, and it had a poster of the first space shuttle flight. And my mom let me order that. When we got it in, my dad went out into the backyard in the garage and built a frame to put that poster in. And that poster hangs in my office now. It hung at my parents' home until I came here to the Smithsonian a couple of years ago. I love teaching, and I love what I do here because I feel like I get an opportunity to really reach out and impact a whole lot of students on a larger scale. The show that I host is called STEM in 30. It is a fast-paced show with teachers in mind. There is rarely a segment that we have on our show that is over 3 minutes long, and that's done very intentionally because we know that teachers are pressed for time, and they may not be able to show an entire 30-minute episode. But we break things down into 3-minute chunks, 3 or 4 minutes, and we put them online so that teachers that are teaching about the International Space Station can show an animation on how to go out into your backyard and see it pass over. We had a show yesterday. We had an engineer from the Jet Propulsion Lab come in, and we did an egg drop experiment with the kids. And then he went over and critiqued their designs. And then we posted the lesson plan online so the teachers could replicate that in their classrooms. We have a lot of fun. It is very fast-paced. And I want to give you guys a little preview of that show. We've had 3 shows so far this year: Star Trek, the Albuquerque International Balloon Fiesta, and yesterday Landing on Other Planets. So this kind of shows those 3 shows as well as our upcoming schedule. So check it out. I should have made you guys dance. That's what we do with the students in our audience whenever we play music like this. One of the things that we try very hard on the show to do is to bring the museum into students' classrooms. We know that there are a whole lot of kids that are never going to get a chance to actually walk through the door here at the National Air and Space Museum, and so we want to bring that to them. And so we bring in leading experts, and we do things live from the floor or on locations to really help enhance a classroom teacher's experience and what they can offer to their students. I do want to introduce our panel. We have some great panelists today. Linda and Peggy are joining us up here. We also have Susan German, who is a nationally board certified teacher, teaches 8th grade in Hallsville Middle School in Hallsville, Missouri. Missouri, that's where I'm from. She has 24 years of experience teaching math and science in the classroom. She's the recipient of the National Science Teachers Association Distinguished Teaching Award and the Science Teachers of Missouri Outstanding Service Award. So Susan, welcome. We also have Deja Wright. She is a 12th grader at Anacostia High School. She is enrolled in honors biomedical science and other science classes. And let me tell you this. I talked with her a few minutes before we started today, and she goes, "What class do you want me to talk about? Do you want me to talk about biomedical or the advanced chemistry?" I'm like, I think either one of those would be perfectly fine for this venue today. She's also actively involved in Global Kids, a nonprofit educational organization focused on global learning and youth development, and we look forward to hearing about her experiences today. And so the first question that I have for the panel, and I'm going to answer this one too because I want to give them a shout out. Did you guys have an influential teacher growing up that really pushed you on the path that you took, particularly in science, but any teacher at all? Who wants to start?
I'll start. This teacher I met when I was in 10th grade when I first got to Anacostia, and her name is Miss Nanda, and she's actually here today. She inspired me to like science, and she actually enrolled me into her honors biomed because she thought that I was smart enough to do it.
Where is she? Stand up. Give that lady a round of applause. Thank you for what you do. How about you, Susan? Did you have an influential teacher?
I grew up in a house full of veterinarians, dad, uncle, grandfather, and now brother, and they're all in practice together. So science was just part of our life. So I always had an interest. As far as a teacher went, Joyce Bricker, she was my high school chemistry teacher. She was the first one to let us really touch things and do stuff. And she made us work like none other to learn chemistry. Stacks and stacks and stacks of work, but it was all related to the labs and the experiments and the things that we did in class. So she would probably be the one that, I mean, I went on to get a degree in chemistry, and she would probably be the reason for that.
Linda?
Definitely. So I'm going to show my age, but it's appropriate here. Sputnik went up. The National Science Foundation put a lot of money into beating the Russians, and in particular, they developed curriculum for junior high schools in math and in science called the New Math. And I was in one of the pilot programs that was developed at the University of Maryland at College Park. That first day of 7th grade, and I went to junior high, I'm too old to have gone to middle school. I walked into that math class, and in that brief 20 minutes, the teacher started talking about the binary system. I was mesmerized. I understood the decimal system in a way, and I'd always been good in really what was arithmetic, but very good, but I understood just looking at the decimal system. And I came home that night and I said, I'm going to be a mathematician. And that's what happened.
Peggy?
I don't know if I can beat that great story, but I can say that my experience with science reflects where I grew up, sort of in the rural part of the country. So my teacher, Mrs. Bess, helped us to understand life sciences by dissecting pigs. That was the first one we did, and we also dissect frogs. We had frogs, and we also looked at eggs, chicks. And we would go through the stages and then hatch them at different time periods so we can study them. It is so vivid in my mind. So that was my start.
For me, I've known I wanted to be a teacher for a long time. It started with Mrs. Bogue in 3rd grade, and then Mr. McCoy, who was a huge mentor of mine in 6th grade. I actually had him as a 6th grade teacher, incredibly hard class. And then I taught across the hall from him for 6 years and really taught me how to work hard and how to be a teacher. And then another one, Mrs. Ackerman, I wouldn't be standing up here on the stage if it weren't for her, because she taught me to speak in front of people in debate class. We got a flyer and it said, sign up for debate class. And I'm like, I don't know about that. Speaking in front of people, that doesn't seem like something that would be very much fun. And after a couple of years of debate class, and I still have my NFL pin, I actually saw it this morning. If you're a debater, you know what that means. And taught me how to speak in front of people without, really tripping over myself too much. So to all of those teachers, thank you so much. And I do want to ask a question. How many of you in the audience can remember vividly the name of that teacher that made a difference for you? Almost every single person in here. And I think that shows the power of teachers. That's incredible. I'd love to hear all of those individual stories, because teachers are where it's at. And Susan, I'm guessing being in your class is a lot of fun. Tell us what a day in your classroom looks like.
Well, here recently, I gave kids the question, how does mass affect the time of fall? So if we were to drop things, how does the mass of the object affect it? And so what I'm looking for their thinking on it. And the kids had to design an investigation around that. And the objects we used was Ziploc bags, and they had 2 different masses in it. They had beads in them. And so a lot of the kids felt the heavier bag would fall faster, and that's actually a bit of a misconception. But I allow them to, I don't judge them for it, I allow them to keep going, because the data will show that they're incorrect. And so the hardest thing, a part of my job, is to get kids to confront those misconceptions and then be willing to change them. So the kids took their data, they saw that there wasn't any difference, but they would still claim, well, I think the heavier bag fell faster. Okay, so we took the bags and we held them up, I held up 2 in class, and the kids are like, can we take slow-mo video with this? Sure. So they all have their cameras out, they're all laying around, they're ready, they're watching me, and I drop the bags and they watch and they can hear, they fall, they hit the same time, they've got video proof. They fall, they hit the same time. At which point most of the kids go, I think they fall Same rate, Ms. Sherman, but I still have a few go, no, the heavier bag fell first. Okay, so, you know, as you can tell, we live in a technology here. Thank goodness for the internet. There's a video clip of the NASA vacuum chamber, the large one in Ohio, and they dropped the bowling ball and the feather. Now, for me, I had to just take it the teacher's word for this growing up, you know, that they would fall at the same rate. So I'm enthralled by this video, the kids not as much, but they finally would agree with me that mass doesn't make a difference. Well, when you get a child to kind of confront that misconception and realize it's time for something new, at that point you can start teaching with the science and put the science education in. And this is just one of a lot of things. I mean, I could take up all of our time with stuff, so.
I think I would have enjoyed being in your class. Deja, you are in biomedical class, honors biomedical class, and you're doing something with a fictionalized murder case?
Yes.
That class has got to be killer. Go ahead.
In this class, I'm analyzing a dead body of the name of Anna Garcia, and I'm learning how to figure out the time of her death, who killed her, or how did she die. And also I'm learning the hair samples, the blood types A, B, B, and O. And also,
Sounds very hands-on.
it's hands-on. Everything I do in science is hands-on, and that's what I like the most about it.
Awesome. Now, Linda, your organization kind of bridges the gap between business and schools. What's the big concern with business right now towards schools?
Sure. In the fall of 2014, the Business Roundtable and Change the Equation released a survey of their membership in which the CEOs, and these are of the big companies with, you know, enormous number of employees and enormous part of the US economy. And their answer was that the skills gap is real and it hurts business, which means it hurts our economy, which means it hurts us individually. Nearly 98% of the CEOs said the skills gap is a problem for their own company. Most of the open jobs, the jobs that they can't fill, require STEM knowledge and skills, and they're having trouble finding people with that knowledge and skills. About 2/3 of the job openings require just basic STEM literacy. That's not talking about an advanced degree, a post-secondary degree. And 42% require advanced STEM knowledge. Yet the applicants who are coming to jobs in corporate America, only a little over a third say that half of their entrants lack basic STEM literacy, what we would think is necessary with a high school degree.
Wow. We had Ian Clark, an engineer from the Jet Propulsion Lab, on our show yesterday, and talking to him between shows, we were looking at some of the upcoming shows, and he was offering some suggestions for people to bring in, and he pointed out that the Jet Propulsion Lab is actively searching out young engineers, particularly young female engineers, and they are struggling to fill all of the positions that they need. And he actually told me the story that on the low-density supersonic decelerator project, they brought in a bunch of fresh out of college engineers and just let them sink or swim, and a lot of them that did really well on that program are now leading important parts of the Mars 2020 program. So there is, you know, we're hearing that all the way up to NASA and JPL. Peggy, was there anything in the report card that surprised you?
Well, you know, I try not to talk about these data in terms of affect, because that's not something the National Center for Education Statistics does, but I can say I was very pleased to see the gaps narrowing for both boys, for girls, and for minorities. Boys were improving as well, but girls were closing the gap. So again, not surprised, but certainly pleased. I think that we have a lot of work to do. I think the contextual variables that were highlighted and so far and what we've talked about today, there are going to be lots of nuggets there if people take the time to go in and look at these data and see how instruction in the schools, instruction outside of school, going to museums and field trips actually has a correlation or relationship with student performance. So no surprises per se, but certainly pleased to see the results showing promise for our students in this country.
Well, and that leads to my next question, which I want to ask to all of you guys is, how do we get kids excited in science? And Susan, I'll start with you.
For me, you have to, I mean, the human brain wants to make sense, and so of things. So for me, to get kids and to garner the interest, or at least the willingness to do what I'm asking them to do, is I create like challenges or questions or things that have a science phenomena type base. So things that they see and they're curious about. So you talk to your students, you look at you listen to them, and you find their interests, and you find things that you can start working with the kids, and that gets them going in that direction.
Deja, how about you?
I feel as though doing hands-on activities makes me like science, and other students in my class like science more, because if I'm reading out of a textbook, I'm not so interested and I don't want to learn about it. But when I do experiments and I visited museums and things like that, then I start being interested in it.
Well, children are natural-born scientists. What's their favorite question? Why? And they come to school with that incredible interest, and they come to out-of-school programs with that incredible interest. So I think we have to find ways to nurture that, and even as you look at the results going through school, we especially have to look at the high school level courses and ask ourselves, how are we nurturing that interest, and how do we rethink the way we're providing education?
You know, I don't want to miss the opportunity today to talk a little bit more about the assessment itself. We have paper and pencil items, yes, the more boring ones that you sort of alluded to, but we also have hands-on tasks. And students are able to conduct experiments with these hands-on tasks. We have interactive computer tasks where students are able to do simulations and sort of have a more authentic experience with the assessment. And then in 2019, we're going DBA, digitally based assessments. And I guarantee you, you are going to like what you see. You're going to be able to go into virtual worlds and move around in a lab and conduct experiments and blow things up and not have to worry about harming anyone. So stay tuned.
There's a great simulation that I use. So the kids have to look at the planets and why the planets orbit the sun, and we're once again dealing with gravity just in a little different situation. And it's out of Colorado, and I call it the Masters of the Universe simulation, because the kids get to decide how big the sun is and how big the planets are, and they enjoy that a great deal. Yes, that garners a lot of interest very quickly.
And Deja, I think you touched on this, the wonder of doing real world stuff, whether it be in the classroom or coming to a museum like this. You know, to see a kid walk through those doors and their eyes just light up, which I'm guessing happened to a lot of you that maybe haven't been here before, is incredible. One of the coolest things that I've seen since I've been here was we had Michael Collins, Apollo 11 astronaut, in for some different things, and he was doing a news interview, and they asked him if he'd go out and look at the Columbia module, and he goes out there. And the museum's open, and there's a group of students sitting on the floor doing a docent tour. And he walks over, and the docent, we had given him a heads up, the docent just introduced him and said, by the way, guys, this guy flew this. And their jaws just hit the ground and their eyes lit up, and it was a brief moment, but they're never gonna forget that. And that's, you know, those experiences that are real world, whether they be in the classroom or at a museum or somewhere else, can be incredibly powerful. we're going to move on to Q&A. So if you've got any questions that you would like to ask, there's a microphone over here. Please come up to the microphone. No fighting over the mic. Just make a nice line and ask your questions, and we'll do our best to answer them.
Thank you. Good morning. Is this on?
Yep.
Well, first of all, thanks. My name is Michael Foyer. I'm the Dean of the Ed School at George Washington University, just up the road here. I have a quick comment for each of you, and I'll be really brief. First of all, Marty, terrific moderation of a panel. I go to a lot of these. This was lively, entertaining, interesting. Congratulations. Galileo's Law, you brought back these wonderful memories of my science experiment, my science fair experiment from, I think, the 6th grade. So write to me, because I have a great story about how Galileo actually came to that insight about mass and falling objects. If you don't know that story, it's a wonderful story. Deja, my kids went to DCPS. You make me very proud. And I just want you to know that you being a senior, if you want to talk about opportunities, talk to me. Not only in the sciences, but for future science educators, thanks to the great work of the federal government and of some of the major foundations that support the improvement of teaching. There are some programs that I want to have a chance to tell you about. Linda, congratulations. What you're doing for the nation is superb. We're all very grateful. And Peggy, you are so right to mention about the assessment. This is an era of greatly flamboyant, extravagant rhetoric. To have something like NAEP that keeps us steady and focused on the data with real knowledge and with real insight, this is a testament to your work and to the work of the department. And I just say, NAEP is another national treasure that we've got to really sustain. So thank you all for a great morning.
Thank you.
Right?
Hi, Linda. Hi. I'm Jerome Dancis. I'm a retired professor of mathematics from the University of Maryland. And I'll start off by saying that I'm aghast that the National Research Council's K-12 science framework is basically arithmetic-free and algebra-free. And unfortunately, the 3 sample problems that were presented were arithmetic-free. Having engaging activities in science class is crucial, but so is arithmetic. And it's crucial that there be both. And what I expect as the National Research Council science framework is implemented across this country is that the number of college freshmen signing up for STEM majors will increase. And then they'll discover that STEM is not arithmetic and algebra free, and the number of sophomores will decrease. On my campus, students who show up in the first biology course, if they have not learned pre-calculus in high school, this means not just passed it with a C, but actually learned it.
Well, and
they will be at risk.
I think one of the things that you'll find is that really good teachers meld the math and the science together. I can only imagine that you do that.
In the example that I gave with the kids dropping the bags, and they computed 2 averages, right? And then the next step from there, we computed the mean absolute deviation, and then used that as a comparison of the means to figure out if the numbers are different. It's an integral part of my class. I'm with you 100%. In fact, my 8th grade students often go to math class and go, "Oh, we're learning how to graph. Don't worry, Miss Sherman already taught us." I mean, it is. I understand your concern, and I can tell you that it needs to be there. The math needs to be there.
Well,
So there are 2 famous quotations. One is mathematics is the queen of the sciences, and the other is mathematics is the handmaiden of the sciences. Guess which one Jerry and I prefer.
no. All right, so I'll give you my favorite arithmetic problem.
I wish we had time. We don't have time to get to that. If we can go to the next question, please. Thank you, though.
Thank you. My name is Claire Caulfield. I'm the education reporter for Cronkite News Arizona PBS here in Washington, D.C. Arizona only has 160 registered physics teachers in the entire state, and the nation is looking at a teacher shortage crisis. What kind of data can we expect going forward when we don't have strong science teachers in our classrooms? Thank you.
Me?
Sure.
Okay. So, several of you in this room were here at Air and Space in September 2000 when we released the report known as Before It's Too Late, the National Commission of Math and Science Teaching for the 21st Century. That's actually known as the John Glenn Commission. John pointed to the Friendship 7 capsule and said, that's the second dummy who climbed into that thing. But that aside, the point of that report was saying it's the teacher who's going to make the difference. And we have to dramatically deepen teacher knowledge and increase the number of teachers. That's why Mike was giving you the push before in math and science. And you know, we laid out an agenda for making that happen, using a budget surplus to provide professional development for every single teacher of mathematics and science, which is the phrase we used, because a second grade teacher is a teacher of math and a teacher of science, even if they don't self-identify that way. And we laid out a very ambitious agenda, which did not come to pass, I'm sorry to say, but parts of it have continued to be picked up. It is very clear that we need to strongly move to make teaching a highly respected, a well-compensated profession, a profession where there is a career ladder to grow and progress over time and to get great success. And we clearly have to deepen the knowledge of people who are preparing to be teachers, but the vast majority of people who will be in schools tomorrow, or today even, in fact, were in schools last year. So we really need to deepen their professional knowledge.
And I think the professional development is incredibly important because I know there are times when teachers are teaching subjects that they didn't go to college for, you know, and so by having that strong professional development does nothing but benefit the students. Did you have something you wanted to add?
Well, you know, I was going to add just one other point. You know, I thought it was really encouraging when we saw more students in these data taking biology and chemistry and physics. But what I didn't say is that we still have an access problem in this country. Access to these types of courses or access to these more advanced courses. Lean over and talk.
I was told you guys were going to be trouble today.
Yeah, we're like two little kids. So no, but the basic point is, and it's well stated by the person that asked us the question, is that we still have a lot to do. And all those students who have access to these courses are taking more of them. There's so many students that don't. Students in rural places in this country, rural locations, minority students in some of the urban schools, they have less access to these science courses. So we do have a lot to do.
Yep. All right, we're going to go to an online question now. Now that we know that teens want hands-on teaching, how can we implement that in classrooms? That's a great question. Susan, how can we implement that?
Well, to be honest with you, in order to quote-unquote fund what I do in my classroom, it comes from me. So there's a whole lot of material that comes from my house. Empty jars, empty cans, containers, you name it. I have tons of it. And I wash it out, clean it out, bring it in, and have the kids use that. I do have science materials, I do have computers, I do have technology, but kids need a full realm of experiences. And you know, we talk about the lack of skills. You can't just always use a computer. You have to have material for the kids to touch and build and think about. I also don't, while kids serve a purpose, you know, if I give kids an engineering task, I like for them to have to look at different materials and try and figure out if it's going to work or not. I don't want everything pre-done, pre-made. I want them thinking as they're going through.
And when I taught elementary school, my budget for the year was $100, which I had to order from a desk order form before the first day of school. And that was the entire budget for the entire year. So I think getting those materials into classrooms is important. All right, we've got an audience question.
Good afternoon. Thank you all for wonderful, encouraging results. My question is sort of building off the other topic about integrating math and science, and we talk a lot about STEM. I'm with the Museum of Science in Boston. My name's Patty Curtis. And I wondered if now with the technology and engineering literacy assessment, NAEP, science and mathematics, do you envision a world where we might assess across or integrated STEM topics and the ability to teach those to those integrated activities? It sounds like you're doing a lot of math in your class. I wonder if you collaborate with your mathematics teachers, and then how might we assess sort of that knowledge? Because in the workplace, we don't just do science for 1 hour and math for an hour. Our application in solving problems has to be an integrated approach. So I wondered if there was a way at some point we could assess in that fashion as well.
Well, Linda and I have decided she's going to take the lead since she has the mic. But we're going to talk a little bit about TEL that we just released. And I think it comes really close to what she's talking about.
Sure. Thank you, Patty. So technology and engineering literacy results, which were released not too long ago, I don't remember exactly when, are really showing the interplay between the man-made world and how you use what you can make in the man-made world to solve problems. It was the first digital online assessment. We hosted a luncheon for a number of folks from the business community to actually try the publicly released items online, and you could have heard a pin drop in that room. Everyone was totally engaged. They were really actually fun. But let me say something from a National Assessment Governing Board point of view. I'm just starting my second year. I'm having way too much fun, and I'm learning an incredible amount. But the one thing that is really dear to NAGB, which oversees policy, is the notion of maintaining trend and seeing progress over time. So in moving to digital assessments, which we are moving to in their entirety, I think it's going to be a very big leap to imagine that we're going to be giving up the math exam or the science exam at any point, because we will lose that sense of progress. And NAEP and NAGB preserve very carefully the authenticity of that trend line and serving as the gold standard in assessment.
We've got an online question next. What steps can be taken to support students performing below their grade level? Susan, what do you do?
Well, I use a lot of instructional scaffolds, and the purpose of a scaffold is to allow students to perform above what they're capable of. So we have, like when the kids have to write a scientific argument, I have a frame for them, and so it gives them specific steps, and it also helps give sentence starters. So the kids, it's a lot to think about for them. So I'm trying to help take away the worry of the organization of the argument and allow them to focus on talking about the science of it. And they're very helpful. I use them, and I as an 8th grade teacher, I have kids the whole spectrum, all the way from they're probably ready for college already to oh my. Those kids have those scaffolds. I have them on some cards and stuff. They set them there, and they can pick that sentence, and they can put the science into it. And it allows them to produce a better argument. And some kids keep those for the whole year. Some kids grab them for a first few times until they get used to doing it, and then they're done with it. It works very well. I mean, you have to know your audience, and so you have to think of different ways of trying to allow them to overcome whatever their challenge is.
If I could add one point, as I mentioned before, one of the things that the business community contributes is their treasure. in terms of supporting high-quality programs. And Change the Equation was formed very early to help companies distinguish between programs that are proven to be effective and programs that just have good marketing materials. And there certainly are many of those. So we have created a database that we call STEMworks. Programs self-nominate themselves, but then they go through a rigorous third-party review, and they need to provide evidence of their effectiveness according to the criteria that a number of our companies have established. Many of these programs are really targeting students who are underperforming or students who need additional enrichment. Some of them include professional development programs, which helps teachers come close to your level.
Thank you.
And Deja, you mentioned earlier that your teacher that's here had said that you were smart enough to do this. How, and I'm not saying you're underperforming at all, because obviously you're not, but how important is that to you to hear somebody that's kind of got your back like that?
I think it's very important because I don't think I would be where I am now if it wasn't for her saying that, because I don't like science and I don't like math.
Oh.
But when she introduced me to science, I started liking it, enjoying it. And
Outstanding. All right, we've got another online question. What similarities do you see between the results for urban and rural schools? Peggy, that one's probably...
Yeah, I want to think about that a little bit. So having this terrific mic problem, so maybe we should come back to me, because, can you hear me? No. Why don't we go around until someone gets me all hooked up?
Okay. I know that I taught in a suburban school, and that my wife actually for a couple of years taught in a very rural school, and the differences just in what was available between those two schools was startling.
Yeah.
You know, even down to just what the standard classroom setup was.
Yeah. Yeah, let me say, I want to pivot back to something I said earlier, but use another data source to make the point. The U.S. Department of Education collects data for the Office for Civil Rights. The assessment or the data collection requires all schools in the country to provide data. And what we're learning from that data collection is that we're having a problem with access to advanced placement classes, IB classes, for students, particularly in the rural area. And you know, it's sort of a bummer that these students cannot get access to these classes. And it's issues about labs, it's issues about trying to get people, teachers, to move to these locations. And so that would be, I would say, the biggest problem we need to work on is for the rural and the urban comparison.
And Susan, you're in a smaller school district.
Yes.
Do you see a challenge there?
Well, I wouldn't have the things I have in my classroom if it weren't for the fact that I know how to write grants. And quite frankly, my school we don't qualify for any minority, any free and reduced lunch. We don't meet any threshold to get money. So I really have to search long and hard to find areas where we can get items, get things in there. And you know, I have it pretty good, and I've made certain that the teachers around me have it pretty good, because I don't want being from a rural school making that the problem.
And I think one of the big takeaways that I have from this discussion today is that really good teachers make a really big difference. So I want to thank you guys for coming in today. Let's give our panelists a round of applause. And I will bring Linda back up to the stage.
Thank you, Marty. Thank you, fellow panelists. Thank you, wonderful audience. I hope that today's discussion of the nation's report card 2015 Science inspires you to learn more and to continue the conversation. Please remember to join others on Twitter in talking about the report card results, and please use the hashtag NAEP, N-A-E-P. If you aren't already, please follow the governing board on Twitter and Facebook to stay informed of our latest news. As Peggy mentioned, you can also visit nationsreportcard.gov to see the full report and to examine the data. And if you go to NAGB, National Assessment Governing Board.org, our website, you can find even more materials, including a news release and the framework guiding the NAEP assessments. In a few weeks, today's webcast and the new video will be available there as well. Members of the media may contact the Governing Board's Public Affairs Specialist, Stefan Harris, who's up, there he is, with any questions. And with that, I say thank you so much for taking your time this morning to join us on this important event. Appreciate it.